Let's look at the law of sines. It's a really easy formula where you can use the angle and the length of A and A, or B and B, or the A's and the C's, or the B's and the C's. But the idea is any four that you use, if you have three of them, you can solve for the other one because then it's just cross multiplying. You'll see as we work it out on a couple of these other problems coming up here. Okay, so this is what we need to look at with the types of triangles that we can solve. So when you're given some information, A, B, and angle A for a triangle, based upon the amounts of those, you could have no solution, or one solution, or two solutions. Or that's if it's acute, and if it's a right or obtuse, you're either going to have no solution or one solution. All of that is based upon the comparison of angle of length A and length B. So when you look here at if A is too small, B is a lot larger, then it's not possible for A to come down and hit the third side. And a lot of that has to do with the angle. For this case, if this angle was a lot smaller and B instead of here was going out like this, then A would be able to come down and hit the well, there would be C here. So this is going to be the length of C. Same thing for this one. And in this case, there's two triangles. Over here, there's just one, and it's this full length. So now when we look at this one, you can see that the length of A is the right amount so that it could be over here, making a larger triangle, where A could be here, making a smaller triangle. That's when length B and angle A stay the same for either of these triangles. So the amount of C and the length of C and the length of B would change. So this is one angle B, and this is a second angle B. I'll call it B prime. And both of those would have the same length B, based also upon A and C. So what your job will be for some of these problems is to first determine if you're going to have no solution because A is too small, one solution because A is making exactly a right angle, or A allows you for a large obtuse angle, or A is the right size so you could actually end up with two triangles. This is a quick summary that I usually put on tests as a reminder, although you have to actually determine or recognize and remember which of these apply. These bolded ones are the obtuse ones, but all of the others apply to this. And this, of course, is the big one really to remember, because that determines whether you're going to have two triangles or just one in most cases. Now, let's take a look at this example here. So in this case, we have the information that the angle amount for A is 34 degrees, the length side A is 6 millimeters, and the length side B is 8 millimeters. So our first thing to do, I'm going to call it simply step 1, is to determine from our information about the types of triangles which ones these should be. Notice that in many of these it was B sine A that you have to figure out to help you do this. So let's do that. Let's figure out what B sine A is. B times sine of A. B is 8, and then we'll do the sine of 34 degrees, and then we will calculate that. That comes to approximately 4.47. Now let's compare that to these. Notice that A is larger than that, but B is larger than that. So it appears that we have a B greater than A greater than B sine A situation, because the B is 8 millimeters. That is indeed greater than 6 millimeters, which is indeed greater than 4.47 millimeters. So this means that we're going to have two triangles. Now that we've determined that, we are going to figure out these things that we don't know for the first triangle, and because there is a second triangle, we'll figure out these also. We wouldn't have to do these if it was only a one triangle or a no solution problem, but we've determined from this that it is a two triangle solution. So what I find helps me to do this, and I'm going to call this step 2, is to set up to help me with all the parts of it. For the first triangle, let's do a triangle symbol. I know that A is equal to 34 degrees. Side A is 6 millimeters. Angle B I do not know right now. Side B I know is 8 millimeters. Angle C I don't know, and side C I don't know. Well, I'm going to be figuring out those things here, but I'm also going to need to find them out for the second triangle. And for those, A will indeed be the same, 34 degrees. Side A is indeed the same as 6 millimeters. I do not know side B, or length B I should say. I do know side B is 8 millimeters. I don't know angle C, and I don't know side C. These three for here and these three for here will be different. And in a way, I don't have to set it up like this. I could just start putting the things in here, but this helps me keep track of it mentally, where I know where I'm going, what I'm using to get these, and then what I'm using to get these. It actually, in many ways, helps me as I'm doing this. Okay, so I am now going to go here to step 3. We're going to start figuring out these parts. And the first thing is I have 2 things for A and 1 thing for B, but these 4 allow me to use the law of sines, which is why we know the law of sines. I can say sine A over A is equal to sine B over B, which means the sine of 34 degrees over 6 is equal to the sine of B over 8. If you cross multiply this, okay, let's see, which way do I want to go with it with writing? Well, 8 times the sine of 34 degrees is equal to 6 times the sine of B. I'm going to divide both sides by that 6. And so the sine of B is equal to this. When you do the sine of B, I guess I will write this out to be clearer with it. The sine of B is equal to 8 sine 34 degrees over 6. I'm not plugging that in the computer yet. I'm going to do it all at one time, so I don't have to worry about any rounding with that, just at the end. If the sine of an angle is something, then we can find that angle amount by doing sine minus 1 of that thing. 8 sine 34 degrees over 6. Okay, is equal to, well, let's see what that amount is. Okay, if you put that into the calculator and you use the sine minus 1 key, let's set this up here. The second function and sine minus 1, and now it's ready for me to enter these things. So I'm going to be doing 8. Actually, what I want to do is I want to do an extra parentheses to make sure I'm doing the top part, then the bottom part, and all that's together. So it's going to be 8 times the sine of 34 divided by, now the 34 is that parentheses, but I want all of this together. So 8 times that is all in its own separate parentheses. Then I do divided by 6, and I'll close the first parentheses. And that gives me an angle amount of 48.2 degrees. Now, if by chance that comes up something really weird or unusual, a negative or a 0.00s and so on, check your mode and make sure you're in degree mode. Because if you're using radians, it will mess up the numbers for some of these functions. You use the radians mode whenever you are graphing trig functions. But if you're not graphing trig functions, come back here and change it. Otherwise, you're going to get numbers that don't make sense and don't work for your problems. Now we could call this 48.21. We could also just simply call it 48. So 21 is, it's not really necessary to go that far with the decimals. In logarithms we would, but we really don't need to here for an angle measurement. 48.2 or just 48 would be acceptable. I'm going to go with 48.2 this time. So that means that angle B is 48.2 degrees. And I can now come up here and put that in this part. 48.2 degrees. So that is one answer. Now we need to find angle C or side C. Angle C is the easiest thing to do. Let's do step 4, because we know that if we have a triangle and we know two of the angles, we just have to subtract them from 180 to get the third angle. So 180, subtract 34, subtract 48.2. Right. And if you put that in the calculator, you're going to get 97.8. Okay, 4, 5, 6, 7, yep, 82.2. So that's going to be equal to 97.8 degrees. Let's go put that up here. 97.8 degrees. And the only thing left for these triangles is to find side C. And for that, we can go back to the law of sines again, because now we know sine A and A, and instead of B and B, we know sine C, we just don't know amount C. But that still gives us three things to work with. So I'm going to draw a line down here, and this is going to be step 5. And that's going to be that sine A is 34 degrees. Divide that by the 6 for A. That's going to be equal to the sine of C, which is sine 97.8. And I'm going to divide that by, well, C. It's what we don't know. So let's cross multiply these. C sine 34 equals 6 sine 97.8. It gets a little tedious, but frankly it works, so it's worth it. 6 sine 97.8 divided by sine of 34. Put that in the calculator and calculate it, and C is approximately 10.6. Let's see what we're doing here. We're doing millimeters. So this comes to 10.6 millimeters. Now there's a quick way to check to see if at least are reasonable answers. So look at the three angle amounts. The smallest angle should have the smallest side across from it. So 34 and 6. The highest one, 97.8, should have the longest side, 10.6. And the in-between angles should have the in-between amount, and 8 is in between 6, 8, and 10.6. So that's not a guarantee that these three answers are correct. It is, however, helping you to be confident that they are reasonable answers, and that means they're probably correct, because if you had done a calculation wrong, something would probably be really off and weird. So this is not a red flag telling us that there's a problem. Okay, the next step to this is to determine these three from the second triangle. In fact, before I forget, let me come over right now and write these answers for this, because I now have at least half credit for this problem. And if I stopped now, I'd at least have half credit. But that's only if your teacher wakes up on the right side of the bed and decides to give half credit that day. Otherwise, you could just say, you didn't do the problem, so therefore you don't get it all. So let's make sure we get all the credit by doing these. The problem is, how do we move over to this one? If we do the same things that we just did, we're going to get these same exact numbers. So something has to change. And here is what changes. In order to find out the angle B for the second triangle, you do not need to do the law of sines. Instead, what you do is recognize that the difference in angles is going to, or that the two angles have to add up to 180 degrees. Let's come back to this for a moment. And over here, when I showed you, you have B and you have B prime. Whoops, I actually, yeah, no, that's correct here. Notice that you have an obtuse angle and you have an acute angle. Well, actually, what happens here, if you think about these two, well, what you get here, if we were to somehow merge these together, you would find that these two would actually add up to 180. How best do I show that here? Let's think of it this way. A and A tells you that these are this is an isosceles triangle. Because it's an isosceles triangle, these two angles are the same. So this one here is also B prime. These two triangles add up to, they are a linear pair, therefore B and B prime add up to 180. So if I happen to know what one of these were, like 48.2 degrees, I could just do 180 subtract 48.2 and I would get the second angle, which is B prime. So let's come back here and let's do exactly that. If this one's 48.2, this one has to be 180 minus that. 180 subtract 48.2. Okay, and 180 subtract 48.2 will be 131.8 degrees. I'll put that one here right now. 131.8 degrees. That's the key between the two triangles, right here. The fact that the two of these have to add up to 180. I'm going to put a star up here and circle it to remind you this one's really important. In fact, let's call this part here step 5. Nope, I already did step 5. That means this is step 6. So step 6 is determining that. Now that we have figured that out, we're at the point like we were when we figured out B here, that we can figure out what C is by, again, 180. Because we know these two angles of the triangle, the third one has to help them add up to 180. So this one will be step 7 to do 180 minus 34 degrees minus 131.8 degrees. So that means that angle C, first angle C, the second angle C here, will be, let's see, that's 165, and then 0.8, that's going to be 14.2. 14.2 degrees. So we have 14.2 degrees. 14.2 degrees. Now we can use the law of sines to find out the amount of side C, because we know that the sine of 34 degrees for A over the length A is equal to the sine of this new angle C, 14.2 degrees, over the amount of C, which we don't know. So now let's cross multiply. C sine 34, 6 sine 14.2, divide by this sine 34 degrees, 4 degrees, and then remember that actually C is just the calculation of that. So if I do 6 times that sine divided by that sine, I get approximately 2.6 millimeters. So this last one's 2.6 millimeters. 2.6 millimeters. Whew. Okay. There's a lot to that one, but now you see how to do it. So let's review these steps here. Get a different color. I'll do that in red. Step 1 is to determine how many triangles it is that it comes to, in this case using B sine A. Step 2 is to set up the logistics of what we're going to need to fill in. That makes it a little bit easier to determine these things. Let me do this box for that last one, because to me it helps seeing what I was figuring out. Step 3 is using the law of cosines to find angle B. Step 4 is using all three angles to add up to 180, or to subtract from 180 the other two. Step 5 is using the law of sines, now that you have 2 things for A and 1 for C, to determine side C. We could have done this with B's. We could have done the sine of 48.2 divided by 8 equals the sine of 97.8 divided by C, and we would have gotten the same exact answer. Just to know that you can do it in different ways. Step 6 was then determining, because the 2 angles add up to 180, determining the amount of length of side B. no, of angle B. Step 7 is then once again finding C by subtracting from 180. And step 8, which I didn't write there, so I'll write it now. Step 8 is to determine the amount of length C by using the law of sines again. Okay. Now this problem helps you see how to do all those parts of it, that they logically make sense following one from another. And here is another one. So what I want you to do is to turn off the video for now, or just stop the video for now, and do this problem. Take as much time as you want, and when you're ready, come back to the video, and I will, as far as the video time goes, I will start talking in just about 2 or 3 seconds. Okay, you're back now, and hopefully you took the time to figure out this and do all the 8 steps of it. And so now I'm going to do them here myself. Step 1. B sine A, that's going to be 4 times the sine of 30 degrees. That's the number 2. So what we have is B greater than A greater than B sine A, which you can see because 4 is greater than 3, which is greater than 2. That means we're going to have 2 triangles. Again, of course I would do that because I want you to practice being able to find the parts and switch over to the second triangle. Alright, step 2. So step 2 is simply the setup, or logistics, of seeing what we're going to get to. So I'm going to do first triangle. Okay, so A and A, B and B, C and C equal sines. A we know is 30 degrees. The amount of A is 3 millimeters, we are again. And the amount of B is 4 millimeters. And I'll also set up for the second triangle. First triangle, second triangle, same thing. A and A, B and B, C and C. Equal, 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 equal. Oh, it gets tedious, but it does work, and we can definitely get the right answer by doing this. So that's what we're going to do. Oh, okay. So I will start with the first triangle, and I will use the law of sines to figure out angle B because I have 3 of the 4 things that I need. So this one's step 3. Okay. Sine of A, which is 30 degrees, over the amount of A, which is 3 millimeters, equals sine of B over 4 millimeters. I'm going to cross multiply 4 times that, and then I'm going to divide by 3. So B, whoops, I shouldn't say B, I should say sine -1 of 4 sine 30 over 3. So sine, so I cross multiply that. Sine B is equal to all of this with the 4 times here. That means that sine -1 of all of that stuff will tell me the amount of B. When you put that into the calculator, it comes out to just about 42 degrees. And so I'm going to put 42 degrees here. And I'm going to put that over here now as well, 42 degrees. This time maybe I'll put them all up one at a time as I get them there. So that gives me that. Step 4, now I'm going to use the 180 rule to get C. So 180 minus 32 minus 42. Step 4. Okay. So 180 minus 30 minus 42. So that's 72. I believe that's 108 degrees. It is indeed. That's 108 degrees. So let's put 108 here. Oh, don't forget the degree sign. And I'm going to come over here and put 108 for the final answer space. Now let's figure out the last part of the first triangle, which is side C. And for that we could use the law of sines again. So for that one, step 5, I have room still here now to do it. So the sine of 30 over 3 is equal to the sine of 108 108 over who knows what. Oops, that C is supposed to be, that's not 3. So this is angle A, so this is side A, and that's an amount of 3. So C, if I multiply this to here, okay, so actually let's do C sine 30 equals 3 sine 108, and then I'll divide both sides by that sine of 30. So if C is equal to all that, we just have to calculate it, divide it all, and we get that C is approximately 5.7. In this case, it's millimeters. Okay, so let's go back up here and put 5.7 millimeters, and come over here and put 5.7 millimeters. Okay, we have completed one triangle. If you worked on that second triangle as you were supposed to, you had to change the angle B, and you did that by doing 180 minus 42, which looks like it'd be 138, I believe. That would add up to 180, yes it would. So that's 138 degrees. And by switching that over by doing 180 minus this one, now everything you do is going to give you different numbers for the C. So these two add up to 168, which means we have a 12 degree angle here for C. 12 degrees. So I'll remind you that that's step 6. I did 180 minus 30 minus 138, and that equaled the 12 degrees for C. But then step 7, I miss a note. Oh, this was actually step 6. Changing that over, I'm going to call it step 6 here. This one's step 7. I know it seems like not necessary to number them, but it helps some people to have a 1, 2, 3, 4, 5, 6, 7, 8 steps to do. So the last step, step 8, is to find amount C by doing sine 30 over 3 is equal to sine of 138 over C. Oh, this isn't C. Again, I did the same thing. I need to do sine of 30 over 3 equals sine of 138 over C. Oh, wait a minute. Now this is where I probably should have been careful to put the A and the C here, because C is not 138, C is 12. Since I have the room here, I'm going to rewrite it here as sine of 30 over 3 equals sine of 12 over C. This is a reminder that it's easy to get some of these little details mixed up. When you're doing it, especially for credit, make sure you're very careful about what you put in, and maybe stop briefly every couple of lines just to look back and see, did I put the right numbers in the right places? So because that was supposed to be angle C, I actually had it wrong at first. Now I have it correct. I'm going to cross multiply. C sine 30 is equal to 3 sine 12. And then I'm going to divide by the sine of 30 here. So C is equal to all that. And when you calculate it, it comes to approximately 1.25. So that means, I come up here, I'm going to put this as 1.25 millimeters. Oh, and over here, 1.25 millimeters. Now, let's do that basic thinking about, do these make sense? We have a 30 degree, 42, and 108 angle. So 30 degrees, 3, 4, 5.7, though the smallest side amount matches the smallest angle. The largest angle has the largest side amount attached to it or across from it, and the other ones are in the middle. So that makes sense. Over here, let's see if the same thing is true. So the 138 is the largest, and it has 4 greater than 3 greater than 1.25. The smallest one is 12, and that is the smallest side compared to the others. So this looks reasonable and makes sense. Therefore, I can be confident that these are the right answers, and that these are the things to write on the side there, as I already did. Let's look at one more type of problem from the Law of Sines. Interesting little type of thing, that you can find the area of a triangle by using not exactly the law of sines, but rather using the sine of an angle. So let's talk first about the types of the little rules for it, little formula. The area of a triangle is 1/2, it's 1/2 base times height. But here we don't really have enough info to know base times height. What we do know is that we can say 1/2 times A times B times the sine of, let's see, in this case, we have A, B, and the sine of C. So notice what we have here is one side, another side, and we have the angle that's in between them. So here's how that would look. I have a triangle sort of like this. I have to keep it from being an isosceles triangle, even though I sort of accidentally did that. So if this is C, and that's 40 degrees, this is side C over here, but that means these are A and B. It doesn't matter whether that's angle A or angle B here. Let's call this one A and this one B. We don't know what they are. Well, we do know actually that this is 10 and we do know that this is 14. We just don't know the amounts of the angles here. We can fill this in though, and it would tell us the area of the triangle just by knowing these three things: two sides and the angle that's in between the two sides. By the way, if we had called this B, C, and A, we would have had B, C, and sine of A. In other words, you can move these around based upon the information you're given. It doesn't matter as long as you have two sides and you have the angle that doesn't match either of those. So it would be the angle that would be in between them, because this one we don't know over here. In this case, so actually let's write that out, because the choices that you could have would be 1/2 AC sine B, or the area could be 1/2 BC sine A. Any one of those will work based upon what you decide your letters are, as long as the angle you have is in between the two sides. So let's calculate this one. The area is going to be 1/2. In this case we're using this because we have an A, a B, and a 40. So we need to put 10, 14, and then sine of 40 degrees. Well, 1/2 of 10 is just 5. It would be easier to do 1/2 of 14, which is 7. 7 times 10 is 70, times the sine of 40. And then when you multiply that out and do the sine of 40 in the calculator, you're going to get the area as approximately 45. It doesn't say what units, just the word units. Therefore, we will call it units, but because it's an area, it's squared. We actually have units times units for these two, so it's actually units squared. So that's what the area is here. 45 units squared. So in this case, just remember that type of formula and you can plug the things in it. The key is simply that the angle has to be in between the two sides, the vertex of where those two sides meet.